So we have to describe all the steps that student use to obtain these result, this graph. Okay, and then we have to draw the diagram because it is 6 marks, so you have to give an answer in detail. Sorry, my mic was off. Yeah. So first, what the student is going to use is ammeter, and for potential difference, what device we use to measure potential difference, to measure current and potential difference?
Is a voltmeter.
Yes. So first, write connect lamp with ammeter. uh, First
Yeah.
step is, yeah, and then connect a voltmeter across the lamp using a power supply. And a resistor in series with
Yeah.
ammeter.
Yeah.
Then we can adjust resistor to change potential difference.
Yeah.
And we can repeat both directions current
Yeah.
by reversing supply,
Yeah.
and plot graph of current against potential difference. Now I will draw here circuit diagram. Whatever we just wrote, we need to draw it. So let's draw first ammeter. This is ammeter, this is positive terminal. Let me draw properly. This is ammeter, positive terminal and negative terminal. Then this is power supply, battery,
Yeah.
and which is, then we have a variable resistor, and then we have a lamp here. This is the lamp, and then we have a voltmeter here. So this is what you need to draw. So right here, variable resistor, lamp, filament lamp. This is filament lamp. This is voltmeter, ammeter, and this is battery.
Yeah.
Yeah, are you done drawing it?
Yeah.
Okay, great. So if we repeat this, we can record the current and voltage at each step by reversing the supply connection, and by taking negative and positive values, and by changing the voltage, we can measure different currents. Okay,
Yeah.
let's go down. Okay, let's read 6.2.
Determine the resistance of the filament lamp when the potential difference across it is 3 volts using physics equation sheet.
Yeah, which sheet has resistance, potential difference, and
Uh, resistance. Where is it? 1 second.
okay.
Mom? Uh,
Yeah.
Where's the rest of the equation sheet? I only found one. Mm, on the table that I'm on. Uh, there's a physics paper, but I don't.
Let me open here.
I only found one.
Isn't it just one?
No, there should be two. And there's the like least useful one.
Right, let me look on the table. This is my tribute to come early and sort yourself out. I shouldn't be having to do everything for you. Yeah.
That's not it.
Oh, that's the maths one, isn't it?
Equation sheet.
Zoheb, where I've got the AQA papers open,
Yeah.
the link, find the paper and there's probably an equation sheet there that you can print off. I printed you off 2 equation sheets.
Oh, that's the one there.
Find it?
This one.
You just put it on the screen.
So
Yeah.
we have current, resistance, and potential difference. So which one we can use? Which has this?
You need the one resistance and potential difference. So potential difference equals current times resistance.
Exactly. So let's go back. And this is the question. Yeah. So potential difference is equals to current times resistance. Now, because here what we have is potential difference is 3. So at 3 from the graph, at 3 what is the current? Can you check from graph at 3 volts?
Three. 1 second.
Look at the graph.
Yep.
At 3 volts, current
At
is
3 volts, current is 0.60. I think that's 0.16.
yes 0.16. So that's how we got. So potential difference is 3, current is 0.16 times R. Can you calculate it? How much is resistance?
Okay, 3 divided by 0.16. 1 second. 18.75.
Yes, 18.75. That's correct. Okay, great. Now let's do next one.
The current lamp is 0.21 amps when the potential difference across the lamp is 6 volts. Calculate energy transferred by filament lamp in 30 minutes. 1 second. Energy transferred.
Yeah, let me
Need
go
the
on the
periodic
sheet.
table.
Yeah, so here we have sheet. What we need to find is
Energy transferred
energy.
equals when
Yeah,
your energy transferred time and current, I think. Or is it 6 volts?
charge flow times. See,
Potential
first if
difference.
you hmm,
Because it says times, the time too, so
what
energy
we have,
transfer.
hmm, first we need to check what we have given. Current is there, right? And so let's write we have current and we have potential difference, we need energy, And if you check the formula for energy from the sheet, we need time for that, right?
Times given.
Time is given. Okay. So if you check this one, energy transferred, charge flow, we need charge, right? And we can
Mhm.
find charge using that formula of current, right? This one's
Yes.
charge flow is
Current
current
times
times,
time.
yeah. So let's use that first, find current, in charge. So current times time, which is, tell me how much is charge?
0.21 times 30. Do you have to change it to seconds?
Yes, change it into seconds.
30 minutes equals 1,800 seconds.
1800 seconds. Okay.
So 0.21 times 800, 1,800 equals 378.
30 times 60 is 1800. Yeah.
Yeah.
And after that, you got charges.
Charge flow is 378.
Yes. And then
So then energy. What was the equation for
energy is
energy?
this, charge flow times
Energy
potential difference.
transfer.
Use this. Just 1 minute. There is someone at the door. Let me check.
Charge flow times ED. So energy times 6.
एक मिनट क्लास ले रही हूँ थोड़ी सी बैठ जाओ. Did you get answer?
Yep.
So what's your answer?
Charge flow times PD is 378 times 6, which is 2,268.
Yes. Good. That's correct. Next question. Go over next question.
The power output of the lamp is 1 watt when the potential difference across the lamp is 5 volts. A student predicts the power output would be 4 watts if the potential difference was doubled. So you need to find the power output equation.
Power output equation.
I think.
Yes. It is asking explain why student is not correct. Okay. Because for the power uh, to, because it says the power is 1 watt when the potential difference is 5 watt, right? 5
Yeah.
volt. So student predict power output will be 4. Okay, but the current does not, because there is a relation between them, right?
Yeah, but for every 5 potential difference is 1 watt in lamp, but if it was double, there'll be 10 potential difference. So that means there'll be 2 watt in lamp, not 4.
Yes, exactly. Yeah, current doesn't double because the resistance of the filament lamp increases, right?
Um,
Hmm.
yeah.
Okay, read say, question number 7.
A
7
baby
kilograms.
bouncer is harness attached to a spring that hangs from a door frame. Figure 7 shows a baby in a baby bouncer in two positions. The baby bouncer should not be used with babies that have a mass greater than 12 kg. So just one reason why.
Hmm.
Uh,
What do you think?
the heavier the heavier the mass of the baby, more the spring will have to extend.
Because spring could be damaged. A mass greater than 12 kg, it might stretch spring beyond its limit. Right? There is a limit of proportionality, which is also called the elastic limit. Okay.
Yep.
Hmm.
In positions A and B, the baby is stationary. Describe the energy transfers as the baby moves from position A to B.
Yeah. So A
Uh,
is this, and you can see here spring is stretched right from position A to B. So
yeah,
in position A, the baby has what type of energy is there?
gravitational.
Yes, gravitational potential energy. And as the baby moves down to position B, it is transferring because it is moving down. So potential energy is transferring to,
Elastic.
yeah, elastic, but also because it is moving, so that is also called,
Equal kinetic.
yes, first it is transferring to kinetic, and then as it is stretching, so it is also transferring into elastic potential energy. And once it stop at position B, so it only has elastic because now it is not moving. So all the kinetic energy and that transfer into elastic potential energy. So there are three energies. For at position A, we have gravitational potential energy. As it moves down, it has kinetic energy, and when it stops at position B, it has elastic potential energy.
Yeah,
Did you write?
yeah.
Okay.
In one position, the extension of the spring is 8 centimeters. The
Hmm.
elastic potential energy stored by the string is 4 joules. Calculate spring constant of the spring.
Yeah.
You need physics equation sheet.
So first, we can use this. Let me go back to, yeah, check which one can we use here. Elastic potential energy, which has spring constant and extension.
Yep.
This one, right?
So elastic potential equals zero point 0.5 times spring constant times extension squared. So
Yes.
that means to get spring constant, you
Hmm.
need to do elastic potential
Hmm.
divided, 1 second, divided by zero point 0.5 times extension squared.
Exactly. This is what you need to do.
So the extension is 8, so that means
Uh,
the elastic potential is 4
hmm.
divided by zero point 0.5 times 8 squared. So 4 divided by zero point 0.5 times 8 squared equals 0.125.
0.125. Okay, yeah, I think this is because we used centimeter. We
Anyway,
have to convert it into meters.
oh yeah. So 0 point, no, 0.08 meters.
Yes, 0.08 square.
8 meters. So 4 divided by zero point 0.5 times 0.08 squared
Hmm.
equals 1,250.
Yes, 1250. Very good. Okay, let's go to next question. Question number 8. Read it.
Scientists develop new models of the atoms as a new particle was discovered. Draw one line from each particle to the year it was discovered.
पानी पी लो जुबैर भाई, प्यास लग रही होगी.
Um, I think the electron found first. Or was it
Hmm.
it was.
Yes.
So that would mean it's 1897 for electron.
Yes.
And then I think was nucleus was found second, I think.
Yeah. Nucleus is found second.
So
So
that
it will
means
be
1911.
yes.
And then proton was found last, I think. No.
No.
Neutron was found last.
Yes.
Proton was found in 1920, and neutron was found in 1932.
Yes, that's correct.
Nucleus was discovered using alpha particle scattering experiment. Alpha particles were directed at a sheet of gold foil. Figure 8 shows the path taken by 7 alpha particles A, B, C, D, E, F, G. Explain how alpha particle A takes the path shown in figure B. Alpha particle A hits the nucleus, so it's deflected off.
Hmm. So this is Rutherford's experiment figure is shown here, right? Alpha particles, this is gold nucleus, and rays are mostly passing straight. Some of them are reflected, some of them get deflect back, right?
Yeah,
So alpha particle A, it takes the path A. Why? Because of repulsion. Because both alpha particles and gold nucleus, they have positive charge. Why? Because nucleus has proton, which is positive charge, right?
yeah,
So because like charges repel, so there will be repulsion because of protons. Okay, alpha particle means what? Alpha particle is helium nucleus, and nucleus is positive because of proton, right? So they will
yeah.
repel. Hmm.
Uh, explain why the path of alpha particle B is more tightly curved than alpha particle C. Alpha particle C is further away from the gold nucleus, so it's less affected by the repulsion from the positive charge.
Yes, exactly. Because alpha particle B is closer to nucleus than the particle C, right?
Yeah,
So that's why force of repulsion is stronger when the distance is smaller. And as the distance increases, the force become uh, like weaker.
yeah.
That's why.
Uh, um, what can be deduced about the atom from the paths taken by alpha particles D, E, F, and G? The
Let's
atom
go with
contains nucleus
D,
or
E,
contains.
F, G.
The atom is mostly empty space.
Yes, exactly. That's why the particles are passing straight without any obstacle because there is no obstacle. That means atom has most of the space in atom is empty.
Yep.
That's why particles are passing straight. So yeah, this was okay.
How is the Bohr model of the atom different from the nuclear model of the atom?
Bohr model explains about the orbits. Remember?
Um, what
And
model's the Bohr?
let me show you here. Bohr model, it shows that electrons move around nucleus in specific orbits. They have specific shells, right?
Yeah,
This is Bohr model. And nuclear model, it shows that electron can orbit at a continuous range of distance.
yeah.
Okay, so Bohr talks about orbit, and nuclear model of atoms, it talks about how electron can orbit at continuous range of distance.
Continuous range.
Yeah, it allow energy levels or shell of specific distance, like it talk about these things.
So Bohr model only contains one shell,
No, there is not one shell. There are multiple shells. Bohr model
but
talks about that electrons orbit around nucleus at a specific distance, and these are called shells or orbits or energy level. But nuclear model, it simply suggests that electron orbit the nucleus, but it does not define fixed path or specific energy level for them. Let me write here, okay? What you should write for Bohr, it says electron orbit nucleus at specific distance, which are called shells or
yeah,
energy level. But nuclear model says that electron orbit nucleus, but it does not define fixed path for them. This is the difference.
but doesn't have a fixed path.
Yeah, this model does not give us fixed path. It does not define fixed path for them, any fixed energy level for them.
Could you explain how an electron can move up and down between energy levels in an atom?
Okay, I might go here. Yeah. So electrons can move up and down according to their energy. When an electron absorb energy, it will move from lower energy level to higher. Suppose an electron is in first energy level, it absorbs some energy, it will move to higher energy level. But if an electron emit, suppose an electron is in third level and it emits some energy, so it will move to lower energy levels. So just write this: when an electron absorb energy,
Yeah,
it it moves to higher energy level from lower energy level from lower.
yeah,
And when an electron emits energy or release energy, it moves,
down.
yes, from higher level to down. This is called de-excitation, and when it move up, it is called excitation.
Yeah.
Bec- yeah.
Airport. Figure 9 shows air being pumped into a car tire. Air particles in the tire move quickly in different directions.
Yeah, air particle in the tire. Sorry, there was a call.
Different
Yeah,
direction.
yeah, in different direction or in random direction. Yeah. Okay, different direction is also fine. Next.
When the tire is at the correct pressure, pumping more air into the tire causes pressure to increase further. The volume and temperature of air in the tire do not change. Explain why the pressure increases as more air is pumped into the tire. When more air is pumped in,
Hmm.
there's less space, so there's more collisions.
Exactly.
So this builds up energy.
Hmm.
I forgot what the energy source called. Is it kinetic?
Energy. It says it is asking explain why the pressure increases as more air is pumped. I think this much is good that because number of collisions increases, so that's why the pressure increases.
Okay.
Hmm.
And then the air pressure in the car tire changes if the temperature of the air in the tire increases. Where the air pressure changes because when temp increases,
Yeah, when temperature increases,
the I forgot what the air is the air molecules.
air particles,
Air particles speed up,
yeah, that means they have
speed
greater
up
kinetic energy.
and have greater kinetic energy, so they crash more often.
Yes, more collision.
More often. So pressure changes
Yeah, pressure also become it also increases.
and increases.
Yes. So I think we are done with this paper.
Okay.
Let me open the another one. I think your mom shared it with me. 2022, I think. This one.
One second.
Yeah, 2022. It doesn't say anything.
One. Okay. I found the equation sheet thingy. So, uh, there's 22.
Yeah, I think this one. Can you match
What's
the
the
question because it
solution?
doesn't say which one it is, if it is 22.
Oh yeah, yeah. I found everything.
Okay.
Okay. Figure 1 shows a large wind farm off the coast of the UK. The mean power output of the wind farm is 696 megawatts, which is enough to power for 580,000 homes. Calculate mean power needed for one home.
Do you have
Give
a equation
each of the
sheet here
ones.
for this
Yeah,
paper? Okay, okay. So for this one, mean power output. Calculate mean power for one home. So what you need to do, just divide, right?
so
Because
mean
this
power
is
would
for,
be,
yeah,
I need to change 696 to regular watts.
Yes.
So 696 megawatts equals, is it 6 million? No, six. How many watts in megawatts?
Um, 10 to the power 6.
So a million. I think that's a million.
Yeah.
Or is it 10 million?
10 to
One
the power
sec.
6. Just add 6 0.
Or it's a million. So
Yeah.
6,960,000.
6,906. Okay. After dividing, you got that?
Yeah, that's what. Yeah, 6.96 divided by 10 to the power 6.
No, because you are converting it into watts, so you
Oh,
have to
times,
multiply.
times. So
Yeah. Yeah.
6.96 times 10 to the power 6. 6,960,000. Yeah,
Six million
divided
nine hundred
by
and sixty.
80,000. So 6,960,000 divided by 580,000 equals 12. So
Um,
mean power needed for one home is 12 watts.
I think it's not 12 because here you have to add 60. It's not 6 million. It will become one.
Is that
So if you divide them, you can just cancel these four zeros from here, these four zeros, right? So you are left with only two zeros, and then you divide it with 58. If you divide this 6,000 uh, by 58, you are getting 1,200 watt. 10 to the power, because 1 megawatt means 10 to the power 6 watt. 10 to the
so
power 6 means 6 zeros.
1 megawatt equals 1 million watts? Isn't that a million?
Yeah.
10 to the power 6. So 1 million watts. So 696. Oh, 696 million.
Yeah.
Oh, I put 6 million. 600
Okay.
equals 696 million
Hmm.
watts. And then you divide, so 696
Hmm.
divided by 580,000. Uh, 1 second. 1,200.
Yes, that's correct. 1,200. Very good. Let's see next one.
On one day, the demand for electricity in the UK was 34,000 megawatts. So there's two reasons why wind power was not able to meet this demand.
बैठ जाओ होने वाली है.
1 sec. When
चलो तो मगरिब
mean
के बाद
power,
आ जाना.
when, oh, there's
नहीं दे दिया था हमने. हाँ
the power
हमने दे
output
दिया था.
of wind farm is 696 million watts, not 34,000 million watts.
Um, yeah, because wind turbines don't turn when the wind is too strong. Uh, with it is not like wind is not enough for this much power, right? For this much
Yeah,
demand. Yeah.
yeah,
And also if it is not windy on that day, so wind turbines may not move and it will not generate wind energy and electricity. Okay.
yeah.
Hmm. Next.
Some of the energy from the wind is used to rotate a wind turbine is wasted. An engineer oils the mechanical parts of the wind turbine. Explain how oiling would affect the efficiency of the wind turbine. Oiling would like it would stop the turbine from like slowing down or being affected.
Yeah, because the efficiency would increase because the amount of energy usually transferred, like the one which is useful, that transfer would increase. This is what efficiency mean. Okay. And amount of energy which is wasted will decrease.
Yeah.
Yeah, because less friction would be there, and this will increase the efficiency.
In most homes in the UK, there are many different electrical devices. Explain why people should be encouraged to use energy efficient electrical devices. Energy efficient electrical devices take up less, or they need less energy to cover. So that means the mean rate of electricity needed by the UK over the country will be lower. So there's a lower demand.
Yes, it would minimize energy demand or electricity demand. Yeah, because more
Okay.
efficient device waste less energy, right?
Yeah.
Hmm.
Um, to help identify the type of rock, the student took measurements to determine its density. Suggest a method the student can use to determine the density of the rock.
Yeah.
Uh,
So
get
density, what is the formula to find density?
density equals mass divided by volume.
Exactly. So first we need to measure the mass. Okay. So we can place, first step will be place the rock on the balance and record its mass in grams.
Yep.
Then we will measure the volume using displacement method.
Then measure volume using displacement,
Hmm. Uh,
and then you divide the mass.
yeah, because it is 6 max, so you have to explain how you will measure the volume. We place empty cylinder under the spout, empty measuring cylinder under spout.
One sec. Empty measuring cylinder under spout.
And then we place and we lower the rock
Lower
into
rock into Eureka can.
displacement, yeah, or eureka can.
Can and the water will come out of the
Yes,
spout
yeah,
into the measuring cylinder.
yeah, and that will be equal to its own volume.
Yeah.
uh, yeah,
Hmm.
and then just record that volume and divide that volume by mass.
Yeah. Mm, the student determined the density of the rock to be 2.55. I forgot what the thing on the right is beside it.
uh, 2.55 plus minus 0.10 gram per centimeter cube. So what are the maximum and minimum values? So for maximum add this 0.10, And for minimum, just subtract it from 2.55, okay?
So 2.65 and
Yes, 2.6.
2.45.
Exactly, yeah. Whatever is given here for maximum add and for minimum just subtract them. Exactly, 2.65 and 2.45. Good.
Yeah. Table 1 gives a density of 5 different types of rocks. Which two types of rocks in Table 1 could be type of rock the student had?
So,
Give types. So
yeah.
is it flint? No, no, wait. One
Yes,
second.
flint.
Is it chalk? As
Yes,
one.
chalk or flint. Yeah, it is chalk or flint. Okay.
Yep.
Yeah, because of the density, if you check the density, hmm,
The student only took one set of measurements to determine the density of the rock. Explain why taking the measurement more than once may improve the accuracy of the density value. Uh, taking measurements more than once may. Uh, Measuring more than once allows us to get a mean value.
yes, exactly. A mean, because we can calculate mean if we have more values, which reduce the effect of random errors, right? By taking mean, it reduce effect of random errors. That's why it gives us more accurate values.
Mhm. An engineering company has invented pavement tiles that generate electricity as people walk on them. Using the physics equation sheet to answer questions 0.3.1 and 0.3.2, what equation is current, potential difference, and power? So current, potential difference, power equals potential difference times current, which is
That's
P
correct.
equals
Yeah, this
V
one.
times power.
Yes,
Alright.
yes, exactly. Let's do
When
3.2.
when a person walks over a towel on potential difference of 4E is induced across the towel, power output is 4.4. So power 4.4 equals
Mm-hmm.
4E times the current.
Yes.
So the current equals 4E divided by 4.4.
4.4 divided by 40.
Wait, 4.4 divided by 4E,
Yeah, this thing we move down always because we have to find this, not this.
which is 0.11.
Yes, 0.11 ampere. So when we are reading after decimal, we don't read it as 11. This is 0.11. 11 if is before decimal.
Yeah.
Okay, that's correct. Good. Let's see 3.3.
Use physics equation sheet to answer questions 0.3.3 and 0.3.4. What equation links efficiency, total power input, and useful power input? So, efficiency equals useful divided by total.
Useful power output and total power input. Yeah, so the first one is correct.
The
Okay.
towers are used to power LED lights in the pavement. An LED light has a total power input of 4 watts. Calculate useful. So efficiency equals no useful equals total power input divided by efficiency.
Efficiency equals,
No, useful equals that equals total divided by efficiency.
yeah, times. You're finding power, right? So you have to find power. So you can use this formula. Power is equals to efficiency times total power.
Oh, yeah. No.
Yeah.
Doesn't efficiency equals useful divided by total? So useful and T and useful. You useful. Oh yeah, efficiency times thing. E
Hmm.
times T. So 0.85 times 4
Yeah.
equals 3.4 useful
Very
tower.
good.
Useful
3.4
power.
watt. Yeah, exactly. Okay, great. So now we are done till 3.4. Rest of the
Alright.
question we can start in next class. Okay, you can mark it. Yeah, you were
Yeah.
saying
Alright.
something? Yes, yes.
Yeah, I've got you booked again for 5 o'clock next day.